Hello and welcome to the fifth and final unit of the Qualified Limited short course on the fundamentals of quality management. In this unit, we will be looking at some of the methods and tools that are commonly applied in quality management. One of the things that quality practitioners are particularly concerned with is the identification of best practice. The best managed organisations are always seeking not only to determine what the best practices are for performing activities, but also how to improve on them. These organisations know and recognise that no organisation is best at everything. Consequently, the desire to learn from others has become firmly embedded in their company culture. The process that is used as a basis to ensure that best practices are ascertained, implemented and improved upon is known as benchmarking. This is one of the most useful and enduring tools for quality improvement. We stress improvement because sometimes there is a misconception with benchmarking that the process is merely about copying the exploits of others. Anyone who has studied the subject, of course, will soon realise that that is far from being the case. Benchmarking, of necessity, relies heavily on a willingness to share information. Closed communication cultures are not well suited to benchmarking. Benchmarking seeks to identify best practice wherever it may exist, and a good place to start usually is in one's own organisation. Once best practice has been identified and standardised internally, then it may be appropriate to start looking outside for ideas for improvement. Internal benchmarking therefore seeks to compare internal operations. This may be between departments, between functions, or perhaps across divisions. Competitive benchmarking is where comparisons are made with competitors. These may be of a product or of a function of interest. Other types of benchmarking include functional benchmarking, that is to say, comparisons with similar functions within the same broad industry or with industry leaders. And then there is generic benchmarking, which is the comparison of business functions or processes that are the same regardless of industry. Occasionally, most notably in the public sector, hybrid benchmarking may be used, which compares departmental performance in chosen areas with public and private sector performance in similar areas. Whichever type of benchmarking is being followed, it is useful to work to an established methodology. It is an 8-step process that begins with the selection of processes for review along with an evaluation of current performance. We then look at identifying partners if the benchmarking is to be external. Otherwise, we will progress on to the 4th step, that is to say, agreement on a measurement strategy. The next stage is then to compare standards and note any difference in performance that we may see. Critical success factors and key performance indicators may be used to help us to make the necessary comparison. When this has been done, we can look towards modifying the relevant practices that may be seen to affect performance. Then we can repeat the comparison and see for ourselves the extent of the improvement relative to our first comparison. Following this, the exercise can be done again with the same or other partners, with other processes, until eventually all of our processes are under continual review. Benchmarking exercises can be extremely useful, with radical improvements often being realised within a relatively short space of time. Internal benchmarking also notably can reveal considerable variation in the perceptions of quality and standards within the organisation, and this can greatly assist management in planning for quality in the future. Back in Unit 2, we made reference to the process approach as one of the 8 principles of quality management. We mentioned flowcharting as a technique to assist us in this. A logical extension of the process approach is what we call business process re-engineering, a technique originally developed in 1993 by authors Hammer and Shampy. It is defined as the fundamental rethinking and radical redesign of business processes to achieve dramatic improvements in critical contemporary measures of performance such as cost, quality, service and speed. This technique is particularly useful for making things like duplication of effort, non-value adding work and bottlenecks clearly visible. With this, lots of intangible costs can be identified and removed. A tool that is often used with BPR is value chain analysis. This is a useful concept in that it helps us to define those processes that are of a non-value adding type. These in turn help to show us where the muda or waste lies in the total system. BPR, or Business Process Reengineering, is a tool that is frequently deployed during a time of economic downturn, when organisations really have to cut down sharply on wasteful activity. Reported benefits of BPR have included reductions in stock holding of up to 50% and improvement in things like delivery performance, where a reduction from, say, 10 to 3 days is not uncommon. Teams form an integral part of quality management and are vital to the improvement process. It is therefore very important to be able to have an objective means by which to assess their performance. A useful guide with which to do this is provided by the Perkins and Michelin team assessment criteria, which again were developed back in the early 1990s and which we teach in our CQI module, Using Quality to Improve Business Performance. Teams may be of the single problem management promoted type, that is to say, established by management to analyse and solve a specific problem or improve a selected part of the business. Or they can be the continuous improvement self-directed teams that select their own problems and are generally voluntary in nature. The first type of these teams may be referred to as a quality improvement team. The second type may be referred to as a quality circle. Another important consideration with teams is their composition. We cannot simply throw a load of people together and call them a team. Poorly assembled teams are prone to failure, so we therefore have to consider team building as part of the quality management discipline. Of course, people have to be selected for teams on the basis of their skills and expertise, but this is not the only factor that has to be taken into consideration. When building a team, we also need to take account of the personalities of the individuals and their relative strengths and weaknesses. For this, we use a theory known as Belbin's theory, after Professor Meredith Belbin of Henley Management College, who devised 9 specific team roles that can be used to achieve the optimum balance within a team. Everyone has a strong and a weak team role, and where a choice exists with regard to who to place in a particular team, this theory, which we teach, can be applied to help us to create the optimum composition of the team. Findings have shown that every person within an organisation has both a functional role related to the type of job that he or she performs, and a team role, that is to say, related to the behavioural attributes that an individual can bring to a team. Another quality-related tool that unfortunately has remained notoriously underutilised in the West is that of total productive maintenance. Yet it is of fundamental importance, concentrating as it does on the quality of the process and hence the product. The reality is that many companies have failed to develop a maintenance strategy in line with technological investment, and the result has been a severe deficiency for many organisations. Maintenance has become management's Cinderella, resulting in chronic losses, often unseen, that need not be there. In order to apply this technique effectively, it is necessary first to identify that plant or equipment that is vital to a process and critical in terms of breakdowns. Then, having done this, subject each item to a detailed condition appraisal, outlining the actions that need to be taken to bring this equipment to its target performance level. Then, enable operators and maintenance staff to jointly develop routines to keep the plant performing at this level. This will help to encourage operator ownership and break the mentality of, well, if it ain't broke, don't fix it. A popular tool in recent times also has been Six Sigma, and this is concerned with process control to high tolerances and process capability to meet these high demands. It is a logical extension of SPC, but is much more demanding. Non-mathematically, Sigma may be defined as a measure of how well data is clustered. A small sigma therefore implies that data is tightly clustered and so exhibits low variation. A large sigma, by contrast, implies that data is loosely clustered and that variation is high. With the Six Sigma technique, specification limits are set at plus or minus 6 sigma, either side of the mean or target, so as to build in a design margin to the product. Teams that have learnt to use these techniques effectively for the solution of real work-related problems are said to have achieved green belt status. At a higher level, individuals and teams may rise to black belt or beyond to the level of the master black belt. This technique is applicable where extremely high tolerances are required or where the number of defective produced from a process needs to be reduced to below 3.7 parts per million. The method used for these types of projects is called Define, Measure, Analyse, Improve and Control, which we otherwise know as DMAIC. Earlier in this course we referred to Dr. Walter Shewhart as the father of statistical process control, and it may be useful to recap here the nature of SPC as an analytical decision-making tool that enables visibility of when a process is working correctly. We've already stated that variation is present in any process and that determining when the variation is natural and when it needs correction is the key to effective quality control. In particular, if a process is in control, its outcomes can be accurately predicted. If it is not, then the outcomes will be inconsistent and unpredictable. The upper and lower control limits of a process will be determined by the sigma value of the process, and processes that are in control will exhibit just common cause variation and therefore form a normal or Gaussian distribution about the mean. Control charts will show whether a process is in control or whether it is out of control. We must note here that control limits are not the same as specifications. Control limits are determined by the process, while specification limits are assigned by people. We'll now turn to another manufacturing tool that has risen to prominence, led by the automobile industry and Toyota in particular. The concept is what we call lean manufacturing, introduced to the West by Womack in 1990 in his famous work, The Machine That Changed the World. With this tool, we have to specify value by product and identify what we call a value stream for each product. This identifies where the value is created, as we discussed earlier in relation to a value chain analysis. Value flows along the stream, such that the customer pulls value from the producer. This is analogous to pumping water from a well. As with other quality management concepts, the pursuit of perfection is maintained through continuous improvement, adding as much value as possible and removing the non-value adding activities that create or represent the mooder. Another principle of quality management, of which we need to be aware, is that of quality costing. Armand V. Feigenbaum, whom we referred to earlier, first rose awareness of the cost of poor quality in the 1950s, with further refinement being made by Philip B. Crosby in the 1970s. The cost of poor quality represents the difference between the actual cost of a product or service and what the cost would be if the process were effective in manufacturing products that met customer needs and were defect-free. The cost of poor quality is important, not least because it speaks in the language of management, that is to say, money. It is related to lean manufacturing in that it focuses on reducing appraisal costs, that is to say, the cost of inspection. As we learnt from Deming, we must cease dependence on mass inspection to achieve quality. The cost of poor quality assumes that there is a root cause for every defect and that defects are in fact preventable. The objective, therefore, is to invest in preventive action to prevent the unwanted external failure costs, that is to say, costs that are incurred as a result of defects reaching the customer in the form of warranties and lost business, and internal failure costs such as scrap and rework. An important tool for identifying product and service features that are critical to certain types of failure is failure mode and effect analysis. The principle behind this tool is one of identifying failures before they happen so that we can avoid them by designing them out. Originally developed by the US military in the early 1960s, the tool seeks to ascertain the likelihood that a failure will occur, the consequence of such failure, and how likely it is that the failure will be detected before it affects the customer. The theory assigns risk priority numbers based on the answers to these questions. Corrective actions aimed at preventing failure are applied when the risk priority numbers indicate that there is a priority. One of the many Japanese gurus that emerged following the early visits of Deming and Duran was Kaoru Ishikawa, whose name is given to what we otherwise know as fishbone charts, so named because of their shape. Ishikawa or fishbone charts are also referred to as cause and effect charts, by virtue of their function, which is to trace back from the effect or symptom of a problem through to the root cause that created it. We should note here that we are moving away from merely treating symptoms to performing a full root cause analysis in order to determine the true cause of a problem. Very often the true cause may not be obvious, and without tracing back to it, the potential for problems to recur or proliferate is always going to be there. This tool therefore has very wide application and ranks amongst the most important for quality practitioners to deploy. Another of the Japanese gurus whom we should be aware of is Genichi Taguchi, who, in addition to developing his well-known loss function, contributed greatly to the science of experimental design. In particular, he taught us how to test for robustness in the design of a product and provided methods for ensuring that quality is designed into a product as opposed to being merely inspected out. This principle is one of the utmost importance in today's age of competitiveness, and naturally one in which Qualified Limited is keen to adopt and promote in this short course series. Another design-based tool is Quality Function Deployment, otherwise known as QFD. This is customer-led design and related to the methods devised by Taguchi. The principle here is to take the voice of the customer and transpose it into the design of a product, resolving any trade-offs with production. The whats and the hows of QFD are represented in what we call a house of quality. That is deployed in up to 4 stages as the hows of one chart become the whats of the next until we reach our best available optimum. And finally, the last tool that we need to introduce is that of knowledge management. And this is increasingly being recognised as an important quality management tool. This discipline, most specifically, recognises the intellectual capital that exists within an organisation. Knowledge has value, sometimes a very high value, and for an organisation to lose it can be very costly, although no such value may appear on a company balance sheet. High labour turnover is a problem of particular significance as it adds, often unnecessarily, to the training budget. Of course, knowledge can be brought in as well as lost, but the guiding principle has to be not to part with hard-earned knowledge and all of its value-adding potential. With knowledge management, a distinction is made between tacit knowledge, that is to say, the knowledge that potentially exists within the minds of individuals, and the explicit knowledge that is codified in the form of books, patents, and other documents. As Deming said, there is no substitute for knowledge. So, ladies and gentlemen, that brings us to the end of our introductory course in quality management. With it, one is hopefully wiser than before and armed with sufficient knowledge and desire to pursue in more depth an understanding of this applied science, and one step closer to becoming an expert in the field. If you would like more information, please contact us on 0161 236 2421 or email us at info@qualified.ltd.uk. Also, please remember to follow us on Facebook, LinkedIn, Twitter and YouTube, where you will find more useful information free of charge.